Our universe consists of trillions upon trillions of molecules. This is a number so large that if each penny represented just one molecule, it would be possible to fill up the ocean billions of times over with just pennies, and still only have reached a fraction of the amount of matter in the known universe. Each of these molecules is made up of even smaller particles called atoms. These atoms bond with each other in unique ways to form the very things that keep us alive, such as water and oxygen. But how exactly do they bond? Is there any order to these interatomic relationships so vital to our existence? Lucky for us, there is. Atoms bond according to principles that can best be understood using the periodic table of elements. Each atom contains a unique number of protons, neutrons, and electrons. The quantity of these subatomic particles per atom can be found by looking at the atomic number on the periodic table. Neatly arranged by increasing order, this table of elements has been organized over the centuries where atoms in each row or column exhibit similar properties to the electrons in that same group. This makes our study of atomic bonding easier. Ionic bonding happens between a metal and a nonmetal. Larger electrons tend to have more pull power, called ionization energy, that allows them to pull electrons away from atoms with smaller ionization energy until they have the number of electrons they want. In this case, chlorine, the nonmetal, has a greater ionization energy than sodium atom, so chlorine takes sodium's electron. Chlorine only needed one electron from sodium to form a complete, stable outer shell. Therefore, this reaction is complete. Covalent, also known as molecular bonding, occurs between two nonmetal atoms that share electrons in order to complete a full outer shell. Here, oxygen and chlorine bond using this process. Both atoms keep their electrons while overlapping their valence electron orbits, artificially filling each other's outer shell. This is the most common form of atomic bonding. Of course, bonding isn't actually this simple. The electrons within the atom's electron cloud, as depicted by the green spheres, usually would be moving much faster and more of a wave pattern. And electrons aren't actually green spheres. They're much smaller and spaced farther apart. However, the green spheres are a good representation of where the orbitals would be within the electron cloud. I hope you enjoyed my video. Thanks for watching.